Bonjour et bienvenue à mon présentation, le Big Rewrite. That's going to be all French I'm going to do for today. Thanks all for coming. So today I'd like to try something different. It's going to be a bit more inspirational, a bit more motivational. There's not going to be really in-depth code examples, so I'm very eager to know what you guys think, so please do send me some feedback. So without further ado, a quick question about myself. So I'm Jeroen Mols, I'm an Android CDE, and I'm also the lead Android developer for the biggest and coolest IoT system in the world, Philips Hue. I'm quite active on Twitter, so feel free to follow me there or ask me any questions. And yeah, let's get immediately started. So, part 1, the brave step. Are you living the dream? Do you have an architecture that is so solid you can literally build your house on it? Is your code so clean it makes your eyes just tear a little? Are you using all of the latest technologies? Are you doing Kotlin architecture components? You're ready to scale your app to new heights and to infinitely expand it? Who here is in that state? Who? Nobody. For the record, I'm also just encouraging you to raise your hands, right? I'm not in this state at all. But if somebody were to be in that state, I would salute you. I would say, congratulations to you. And I'm quite sure everyone else in this room would be jealous of you. But I would also be a bit wary, to be honest. Because did you check your crash reports lately? Are you reading one-star reviews? Or maybe you simply don't test, because yeah, you can't have any bugs if you don't test, right? Truth be told, not every project is like this. Only happy developers. In reality, we have bugs that come and chase us. And some bugs love us so damn much, they just keep on coming back and back. Or crashes that pop up at the most inconvenient times possible. Immediately after a release on Friday, anyone? And sometimes shit just simply hits the fan. And nobody likes being like this guy, right? But yeah, it happens. And what all of these things do is they push us into a reactive mode, a firefighting mode, where all we're doing is we're fixing stuff. Oh no, the CI is red, let's go and fix that. Oh no, tests are failing, let's go and fix that. Oh, user is complaining, let's go and fix that. Oh no, this happens and that happens. And you're all reacting to stuff, but you don't really have any time to make things better, to get out of this mess. So that begs the question, how do you? No. So you can actually keep up with it for quite some time, if you want, but everybody breaks at some point. No matter how much coffee you drink, you can't sustain this mode of reactive operation indefinitely. So that begs the question, how do you get out of it? How do you make things better? And then somebody in your team goes like, well, what if, nah, never mind, it's too crazy. And then the rest of the team is like, no, please do, chair. We're really in a pickle here. And then he continues, yeah, what if we would start over? And then the entire team goes like, yeah, start over. We can just throw away all of the legacy. A green field. We will do things right this time. We have the right team in place. We're going to do Kotlin, architecture component, RX Java. We're going to test the shit out of this thing. It's going to be great. We will be really able to scale our apps to new heights. Our users are going to love it. Our developers are going to be happy again. And let's face it, we're not Google, we're not Facebook. Our app surely isn't that big, right? It should just take us a few months and we'll be out of this mess. So, part 1, our app is in a bad state. We're constantly firefighting, team is unhappy, we need to do something radical. Let's start over. Now, reality kicks in. So one of the very first requirements you're going to get if you start over is that your app has to be so-called feature neutral. That means that people in your organization are going to tell you, okay, it's going to be fine to leave our users waiting for a few months, But then we should at least give them what they currently already have. So the new app needs to have all of the features the old app already has. So forget about building a skateboard first, and then a bike, then a car, then a Ferrari. No, you're going to have to build that Ferrari from the get-go. So the amount of work you'll have to do is going to be bigger than you thought it was. And who here likes backlog refinements? Oh, nobody. Can you imagine doing that for a complete app? It's going to take you days, if not weeks. Imagine writing all of those user stories. And now think back at the last estimate you gave. Was that very accurate? Because chances are, if you're working in a legacy code base, that your estimates aren't accurate to begin with. Estimating stuff is probably the single most difficult thing you can do in software engineering. And none of us are trained to do so. So what ends up happening in a lot of cases is that, like we always are, we're happy folks, we're optimistic, so also our estimates are going to be optimistic. So we have more work than we thought we were going to have, and we're going to think we can do it in less time. And then if we actually start building those features, we're going to realize, hey, there is no documentation. So how do these features actually work? What are like the nitty-gritty little details we should watch out for? What are the corner cases? How should it behave under X and X circumstances? And all of those little details are going to be tucked away deeply into the source code. So that means that if you're going to rewrite a feature from scratch, you're going to make a lot of rookie mistakes. And all of those rookie mistakes are going to take you a lot of time. And you're also going to make those rookie mistakes in part of the apps that weren't problematic to start with. So you're going to spend a lot of time not really adding new value to your business or to your user. Think about it this way. If your app is complex enough to be rewritten to start with, it surely also must be complex enough that all of those requirements are tucked away deeply somewhere, right? And then, who doesn't love these guys? Those always happy, super excited designers that come up with new ideas? Amazing, right? Can you imagine how many new ideas they're going to come up with in those months you're going to spend rewriting your app from scratch? And they're also going to say like, hey, if we rewrite our app, we might as well change the design, right? Because we're building every screen from scratch anyway. But all of those design changes, they're going to have tiny little usability issues, or inconsistencies, or some screens bluntly may not work at all. So instead of building every screen once, you're going to have to build a few screens more than once. So designs are going to change, they're going to keep on changing, and that's going to cause a lot of rework. Same is going to happen for your features. People in your organization, they're going to come up with new ideas while you're building the app from scratch. They want to change the existing features just a tiny little bit, causing new issues you have to deal with, and so on. And because of those ever-changing designs and ever-changing requirements, it's just a lot of extra work that you didn't anticipate it to start with. And do you remember that old app you had? Well, funny thing. It turns out that your users are not going to keep on using it. So you'll at least have to do some maintenance on it, right? And yeah, if suddenly your crashes start spiking, yeah, then obviously you have to fix that, right? If your company decides to rebrand and change their color scheme, well, obviously. If Android P introduces new background restrictions that you have to deal with, yeah, then obviously. And so on and so on. And that's problematic for two reasons. First, every fix you make, every new feature you add to the old app, you'll also have to port it to the new app. So that's going to be a lot of double work. And secondly, you're going to lose a lot of your precious development capacity trying to fix the old app that you thought you would have for the new app. So your new app is going to delay. And did you ever consider, like, how on earth did this app get into this state to begin with? Was the previous team then completely and utterly incompetent? A bunch of clowns? Well, possibly. But likely they're not more incompetent than anyone else in this room. The truth is simply that in every project we do, shortcuts are going to be taken. We're going to make a tiny little change, tiny little hack, just to get back on planning. And that's what we call technical debt. So it's basically code that does what it's supposed to do, but it's completely and utterly impossible to maintain, let alone to build further upon it. And like with any debt, somebody has to repay it. And that person is very likely going to be us. And then, whenever you finish your rewrite, what's going to happen then? Are you just going to put months and months of work with multiple people live with just the flick of a red button switch? That's bound to go wrong, right? Also, the idea here that new code would be better than old code, that's just patently absurd. Because while the old code, it may look bad and have maintenance issues, at least it has been proven to work in production. It's battle-hardened. It has all of those nitty-gritty bug fixes. Whereas the new code, it hasn't proven anything yet. So there's a huge technical risk in launching your app and putting it live. But the risk isn't just technical. Because also, people don't like change. So your users, if you give them a big redesign of your app, the bigger the change you give them, the more of a hit or miss it's going to be. They're either going to completely like it or completely hate it. There's not going to be a middle ground. For instance, Skype, they redesigned their app a year ago. And they made this tiny little change where they just, on the list of contacts, you used to have a label next to every name where you could see who was online. So you could just on the list see everyone who was online in like one glance. Then they changed their design and they just dropped that label, so now you had to press a contact, go to the details screen, and then only there you could see whether they were online or not. People went nuts over that. Over that tiny little change, they just bashed them with 1 star after 1 star. So, big bang changes, they're super risky for you, but they're also super risky for your users. So, reality kicks in. It's going to be a lot more work than we thought it would be. Our estimates are going to be overly optimistic. Things are going to keep on changing that we have to deal with. We'll lose development capacity to the old app. We're probably also underestimating the qualities of the previous team. They probably weren't so bad to begin with. And then the big bang launch, the first launch, is going to be super risky, right? Okay. Part 3. Ship, ship, ship. Because of all of these changing things, you're going to fight very hard as a team to try and get this app shipped. But because so many things changed, you're going to miss your deadline. You will have fought hard, you will have done everything you possibly could, but the deadline you're going to miss it. And you're going to set the next deadline, and you're likely also to miss that one, and the next one. And the next one, and things will slowly but surely keep on slipping with no clear end in sight. And then all the time you realize, what are we doing? We're leaving our users in the cold, right? This rewrite, it won't really bring anything new. It's not going to bring any short-term value. We're surely not fixing those bugs or providing those features that users have been asking for the last few months because we were so busy doing the rewrite. So, slowly but surely, users are going to start complaining like, hey, have you abandoned this app? Why aren't you updating it anymore? And 1 stars are going to start coming in. And also your competition, they're not going to sit still, right? So the head start you had over them, if you rewrite, you're basically handing that over to them on a silver platter. They suddenly have time to catch up. This is exactly what happened to Netscape. They used to be the most dominant browser in the world. They had 70 or 80% market share. Then they decided, okay, we have to rewrite. Took them more than 3 years. The first app launch was buggy as hell. And we all know what happened, right? Microsoft just got up and Internet Explorer took over. So when users start to leave, or the prospect of users leaving, it's gonna make some people in your organization super nervous. And that's worse than you may think, because perception of people is going to shift. Your management is suddenly going to look at the rewrite as like, hey, why isn't this working out? We're missing deadline after deadline. It's becoming more expensive than we thought it was. And we still have no way to ship. Users are complaining, competition is catching up, so perception is going to is going to turn against you. People are going to look at the rewrite as a broken promise. And okay, it's not our fault that stuff kept on changing. We can't do anything about that. But we're going to be looked at as the responsibles for not being able to ship the app yet. And so that can really put the team down. I've been in a situation where we decided to keep the Android app as is and refactor it, and then on iOS to just rewrite it from scratch. And by no means I want to make statements here that the Android project was great. But what I can tell you, those iOS folks, they had it rough, man. It was really rough. If the organization turns against you and you have to do overtime and they throw more resources at you, making you go slower and slower, it's not nice. So with this tremendous amount of pressure, what that's going to do is it's going to push the team so hard that you're slowly but surely going to let go of your principles. You're going to say hey, those espresso tests we were writing, yeah, turns out they take a hell of a lot more time to make them run completely stable. We didn't anticipate that, so let's skip them from now and let's do that later. Or unit tests, okay, let's also skip them. Or, yeah, here, let's make this quickie hack just to make some speed. And without you realizing it, you're going to start accumulating technical debt. And then you could say yeah, hey, but we're senior developers, you can resist this, right? Sure you can. And the more firmly you're standing in your shoes, the more senior you are, the better you will be able to resist this. But to be very frank, in my career, I've seen maybe 1 or 2 people who will be able to resist this amount of pressure indefinitely. I personally, I would cave in, I'm sure. And those people who would be able to resist, I'm not really sure if they would still be allowed to work for that company. So, when the pressure starts to increase, you're going to take shortcuts. Technical debt accumulates, and then the question is, are you really better off than you were before? Keep in mind that every project used to be a greenfield once, right? Do you really believe that those developers didn't have the best intentions? Do you really think that they were all incompetent? No, right? So, what's a better way to approach it? Refactoring. Refactoring is where you make your code step by step a bit better without changing its internal behavior. So you're going to step by step try to improve the readability, maintainability, understandability, maybe even architecture of the code. And the steps you take can be either super big or a bit smaller. That doesn't really matter. They just have to fit in one sprint, so you can keep on releasing and battle hardening your code. And while refactoring also has its challenges, it has quite a few interesting benefits. Because if every step you make makes your code better, then you're making your entire code base better by design, right? Over time, you're only going to be better. Whereas if you rewrite it, you don't know, because you start better and then you start taking shortcuts, so will you be better off or worse off? Plus, you'll keep the ability to ship. You don't have to leave your users waiting for months in the cold before they get something new. You can keep on shipping even new features and so on. You don't have any loss of development capacity on the old app. You don't lose those years of bug fixing on the non-problematic features. So there's quite a few interesting parts about refactoring. But if you want to make it successful, you need to have the buy-in of the entire team. Because by no means is refactoring a sexy thing to do. It's going to be frustrating, it's going to be dull, so you need to have the buy-in of the entire team. You need to know why you decided not to rewrite the app, why that would be a broken promise. And even when somebody new joins the team, help them, educate them, explain them why you made the choices that you did. Be open, be transparent. Because you cannot do this thing by yourself. If you're making the code better and your other team members keep on doing what they were doing, then you would be like mopping the floor while the water tap is still open. It's an endless work. So the very first thing you need to do in order to make your code better is stop making it worse. No more hacks, no more patches, no more quick fixes. From now on, every step you take needs to be a step in the right direction. This is what we usually refer to as the Boy Scout rule. And while the Boy Scout rule is super powerful, and can already bring you quite a long way, it's not enough. Because some part of your code is just so bad that you need to do something more radical, more dramatic in order to make it better. But more on that later on. And it also, obviously, if you write some new code, that needs to be like the golden standard that you want to attain, right? There you need to focus on maintainability from the get-go. So, when we stop making it worse, we can actually start making it better. First, let's set the goal. How do you want your technology stack to look like? Do you want to have a Java app or a Kotlin app? Do you want to use architecture components or RX or both? What are you going to test? And maybe even importantly, what aren't you going to test? Will you use any coding standards? And so on. Set those goals, because then everybody will work towards them in the same direction. Plus, goals will also help you to monitor progress towards them. If you say, we want to be a 100% Kotlin app with 70% of code coverage, it's super easy to track that, right? Then you can just start today, you measure in 3 months, you see how much you've progressed, and then you can decide, should we do more or should we do less? Plus, it also helps you to basically gamify it a bit, to appreciate progress. Because if you're refactoring, it's likely going to be, at least in the beginning, that you change a little bit here, a little bit there, a little bit here, a little bit there. And all of those little changes will always be a bit compromises that you have to make. So then, at the end of the day, you could feel like, yeah, what did I accomplish now? I just compromised the entire day, where you actually drove stuff forward. So setting a clear goal helps you gamify that a bit and appreciate progress better. And then, we need to have a really good CI in place. Who here is using pull requests? Okay, that's almost everyone. That's a really good thing. Because what pull requests do is they allow you to basically decouple the stable version of your source code from what's new in development. And then you can do all kinds of quality checks before you merge it in. So you basically increase the overall quality of your code, which is great, right? But pull requests actually have one major disadvantage. Because if you create a pull request and you do all of those checks, you enforce a review, you run all of the tests, you build, you run detect, you run lint, you check the code style and so on, that takes time. Imagine if that takes like half an hour. Yeah, then I would create a pull request, takes half an hour, and then I would know like, I forgot to check in a file. Okay, wait another half an hour, then somebody can do the review, then I have to wait another, so then I incorporate the changes, wait another half an hour, forgot to fix a test, okay, I have to fix a test, another half an hour. So before you know it, you're going to be spending a complete afternoon just integrating that single branch. And that's bad, because that's a lot of process, and people are going to, by nature, try to avoid that process. So what could happen is that people in your team decide to, instead of making small pull requests on a very regular basis, that they would only make a few pull requests per week, very big ones. And that's bad. Because I don't know about you, but if I have to review a pull request, which is more than a day's worth of code, like 2 days or even more, for the life of it, I can't do a professional review on that. It's just too much code. I can't see the trees through the forest anymore. So then the quality of my review goes down. And also, if that pull request is so big, yeah, it's also been detached from development for a significant amount of time, so you're going to have a harder time merging it in. You're going to have more merge conflicts. And let's face it, every merge conflict you solve is just flipping a coin and hoping it ends up in the right spot, right? So your pull requests need to be small. Everybody needs to make multiple pull requests per day. And the only way to enable that is to make sure that your CI is blazingly fast. All of your checks should run in under 5 minutes. And it also needs to be stable, because you don't want to have any random failures. Random failures will make your team go nuts, and you will start ignoring the CI. So a good CI is one that never fails, is super fast, and if it does fail, then people take the utmost attention. And you'll have to write tests. There is simply no way around it. Writing tests doesn't help you to ensure that your code is actually doing what it's supposed to do, but it also helps you to make sure that that code keeps on doing what it's supposed to do. Manual testing doesn't scale. Your app is only going to get bigger over time, and yeah, you can't always retest every scenario through it, right? Yeah, obviously you can, but then you're just only going to be testing after a few months. So, if you're not writing that many tests yet, the best way to get started is to stop fixing bugs. Enforce the rule that you can only fix a bug if you first prove that that bug exists with a failing test. And if you do that and you fix it, you're not only sure that that bug is actually fixed, but you're also sure that it doesn't reappear. Okay, given you could have still fixed the wrong bug, but then at least it was a bug. So. And then a typical thing that also happens is spaghetti code. Who here has spaghetti code? Okay. So what spaghetti code is code where everything is linked to everything. And that's very hard to refactor, because if you make a change to this class, then suddenly something changes to that class, and then you have to change something here and there and there and there, and you just have this cascading effect all over the place. So it's very hard to make spaghetti code better. And the reason for that is that you're missing clear contracts. Your code should be decoupled from each other with clear contracts. And one of the best ways to get a clear contract in place is to modularize your app. Modularization doesn't just bring better contracts. It also speeds up your builds, it allows you to do instant apps, and it will significantly reduce the merge conflicts if you're working with multiple developers on one app. Take, for instance, login code in your app. I think everybody has some kind of login in their app, right? Imagine if that code is scattered all over the place and you then want to swap social provider to do the login. That's going to be a mess, right? Wouldn't it be better if just all of that code was somewhere in a module and that you could say like, hey, start login activity for result, and the result you would get is just a token which you can use to do all of your communication to the backend? And it's very easy to do that. You just take all of the code related to login as is, you copy paste it to a separate module, you fix all of the conflicts, you then polish up the interface just a little bit, you don't touch all of the rest of the code, and boom, you suddenly have your first module. And that's actually super powerful, because if you modularize your app, you can divide and conquer. You can basically split your app in parts that are problematic, less problematic, not problematic at all, and then you can, per module, decide what you need to do to make it better. For instance, for the login module, you could decide like, hey, this code is bad, let's refactor it to make it better. And you can, good choice. Or you could say like, yeah, this login code, it's really, really messy, it's really bad, but to be frank, we don't really innovate much in the login space, so we don't really touch it often, so let's just ignore it. At least we've isolated from the rest of the code. Also an excellent choice. Or you could say like, hey, this login code, it's just, yeah, it's a disaster, let's throw it away and rewrite it from scratch. Also a good choice. And now you may say like, hey, what's up with you? You're advocating not to rewrite, and suddenly you're saying you should rewrite? Yeah, because some parts of your code can be so complex that you could still refactor them in a better state, but it's going to take you so much time and so much hassle that it's just more efficient to rewrite it from scratch. But if you modularize first, you make the problem smaller. You're only going to focus on those parts of your code that were problematic to start with, so you're not going to lose any time on writing the about screen from scratch, for instance. So it's more focused. It's also isolated, and you can feature toggle it. So you can just write your new login module, and you can already integrate it and develop run all tests over it. You can incrementally ship it to users, do A/B tests to see if it at least performs as well as the old module. So you can do a lot risk management if you have modularization in place. And then, if you read any book on refactoring, one of the first things that book would tell you is that you need to have tests in place. Because every change you make after that, you need to run all of the tests, and you need to know immediately if the code still does what it's supposed to do. But this is a bit challenging, right? Because legacy code almost by definition means that it's either poorly tested or doesn't have any tests at all. So how do you make code like that better? Well, I don't really want to dive any deeper into any particular testing strategies or refactoring strategies here, but what I do want to say is that we have one of the most powerful IDEs in the world at our disposal. Who here still renames classes by hand? With that I mean you rename the class in the header, then you go to the file, you rename the file, then you go everywhere in the code base and you update all of the references. Nobody? One person? So did you know you can do that with Shift F6 and Android Studio does everything for you? But that's not all. You can also move code around. You can extract a subclass. You can inline an interface, extract a method, inline methods, extract variables, constants. You name it, Android Studio can do it. Kotlin and Java are statically typed languages, so the amount of stuff an IDE can do is amazing. You just have to learn how. And if you learn how, if you make that investment in your career, your life isn't just going to be a lot less dull, because let's face it, who likes doing that kind of repetitive work? But you're also going to make fewer mistakes. So make sure that you get the most out of your tools. And then keep on releasing. Release, release, release. That's the single most important thing you can do. Because, yeah, only when your code is in a user's hand, you're going to have the final seal of approval that that code does what it's supposed to do. And we all write bugs. I made my career of writing bugs. But what would you rather do? Ship an app with 2 weeks of work and then fix 5 bugs? Or ship an app with, 2 years of work and then fix 500 bugs? I would pick the 2 weeks one. And I'm not saying it's going to be easy. Refactoring is hard. We are in a very challenging line of business. So it's going to be frustrating. Sometimes you're going to feel like you're juggling code around. That's okay. Don't worry. We didn't go to the moon because it was easy. We went to the moon because it was hard. Have faith. You'll manage. For instance, in my team, we're struggling to modularize our app. We already tried to extract one module like 3 or 4 times, and we always failed at it. Which is okay. I'm proud of my failures. Because a failure never is a complete failure. We learned a lot of the code while we were doing that. So we learned a lot more. We polished up some of the contracts. We cut quite some of the spaghettis already. And now I'm fairly confident that if we take a new step at it, that we'll actually be able to extract that module. And the modularization will also go easier over time, because the more modules you have, the less spaghetti will be left. So a better way. Refactor your code step by step. Make sure that you work as a team towards a clear goal. Write a lot of tests. Have a good CI in place to run them for you, so they're fast and stable. And then don't be afraid of making bigger changes, but manage the risks by modularizing your app first. And keep on releasing, releasing, releasing. Have faith. You'll manage. So we've already reached the end almost. So I hope that next time somebody starts talking to you about rewriting your app, that your reflex will be to run away as fast as you can. App rewrites hardly ever work out. They're not a silver bullet. But is there then really no room for a rewrite at all? Well, sure there is. Stuff is hardly black or white. There's a lot of grays in between. So for instance, if you want to dramatically change the technology you're using, then rewrite it. Facebook did. They had a web app and then they moved to a native app. Good choice. So they rewrote their app. Or maybe you just have a super small app and you can rewrite it in 2 or 3 weeks. Sure, by all means, do it. Or maybe you want to change the backend you're using, radically change the architecture, have a new design in place, and then also even change the mental concept of your app. Yeah, sure. Then you can also do that. But keep in mind that if you do that, you're not improving an app anymore, right? You're basically just developing a new product from scratch, which is completely fine. But then you need to realize that product development is risky. So you need to accept that risk. So rewrites, they're risky. And they take a lot more time than you think they would take. So try to reduce the risk as much as possible. Not just for you, but also for your user. Make sure you have a system in place so you can keep on delivering value to your user. And test your code as quickly as you can in production. Because only then you will know that it works. And if your users are unhappy, then your entire reason to exist starts to fade. So with refactoring, you can make your code incrementally better. You'll make your code base better by design. But with modularization, you can even take those bigger, more risky steps to dramatically move things forward. automate your testing as much as you can, and release, release, release. And then as a final note, our apps are only getting bigger over time. So that means that the cost of rewriting them from scratch, that's increasing every day. So the chances of that happening is decreasing. So whether we want it or not, these skills of being able to take a legacy code base and make it better in a professional step-by-step way, we will need those skills regardless. It is challenging, but have faith. I'm confident that the 10x developer rockstar ninja like you, or at least that seems to be what your LinkedIn profile says, I'm confident that you can manage that. So the image credits, a big shout out to the top one, Clément127. He's actually French. He made all of those lithography images, or most of them. I really encourage you to Google lithography. It's going to be the best afternoon you lose this month. And I have some further reads. If you're interested, you can find quite a few interesting reads online about this. And that's basically it. So I'm Jeroen Mols. I'm rather active on Twitter. I also every month try to write a blog post. So I want to thank you all for coming to my talk. Are there any questions? Yeah, there's one there.
Thank you for your talk. To be honest, I'm a user of the Hue apps, both on iOS and Android. And I was wondering if your iOS team did really survive the evolution from the version 1 to version 2, because it was really rough on the store. And did they manage to survive this?
So the project where we did the rewrite, that wasn't the Hue app. So that was a different app. Now in Hue, we actually also did a rewrite where we basically moved to a completely new concept. So we used to be super flexible in like how you could group things, and then we wanted to help people better to like organize everything in rooms and have like a very hierarchical structure. Plus we wanted to introduce a new SDK. So that's why actually we also a few years back we rewrote our app from scratch. And to be honest, yeah, it is what it is, right? So we still consider like we have a lot of legacy code, and we still have a lot of things we'd like to refactor and improve, and it's just, I don't think anybody is really in a state where they say like, okay, this is like, I can't think of anything to refactor anymore. So does it answer your question?
Yes. What I was thinking is, it took, as you said, it took some time.
Yeah.
And most certainly, most of the people managing you wasn't maybe that happy with the results. And how did you lead your team to keep trying and get better?
So what basically happened is, so we rewrote the app. We then, I guess, we launched a new version somewhere last year, I guess. That all happened way before my time. So I wasn't involved in that. And what we then did is, like, we're now trying to take the thing that we have and we just try to make it incrementally better like everybody else does. So we're now applying many of these ideas and strategies in order to make it better in a way, and then you'll realize that, yeah, the key to good endings is bad beginnings, right? So we try to make the best of it and just try to do better every day, and we know that we still have a long way to go, but it is what it is, right? The main idea is like, imagine if we would start over. So for instance, Philips Hue, if you would look at the wireframes, we have like 470 screens. So if we would like to build those screens from scratch again, I'm quite sure that's not going to work out the way we would want it to work out. So this is what it is. It's just a challenging business to be in, app development in general. And it's only going to get more challenging over time because everything only gets bigger and not smaller. So.
Okay, thank you.
Yep. There's, yeah.
Here. Left.
Whoa.
Okay. So thanks for the talk. You were talking about CI, having a great CI pipeline. What are you guys using for your stack? And how about follow-up question to that. Are you using CD too, like deployment and continuous deployment? Or?
Yeah, so we're moving towards the deployment stage. What we currently have, and it's a bit of a downer of being in a big company, they're very protective about their data and their source code, so we couldn't use an external service. So what we now have is our CI is actually, we have 2 CIs, because we really wanted to hit the 5-minute mark. So what we basically do is we have a local CI so that we can hook up devices to it and then run espresso tests on there. But then we also have a cloud CI where we run lint and detect checks and so on. So every time when we create a pull request, we basically spawn 2 builds in parallel, and then they both clock out somewhere between like 4 and 6 minutes. So we actually can hit the 5-minute mark. But it's like, yeah, it's a rather complex setup in order to like cater for our needs, right? And now we want to drive it a step further towards continuous deployment. But I think the main challenge there is, as an organization, we're not really set up to cater for that yet. So as a development team, it's fairly easy for us to just have a stable CI pipeline and make sure that the quality of what we deliver is up to the mark. But still, a lot of people in the organization, they expect to then do extra quality checks on top, and then first the beta testing, and then this, and then that. So then it's a lot of organizational problems we have to overcome. We still have to like improve the quality of our outputs, obviously, but I think, yeah, we're moving towards it. So
what's the actual stack? Like, what's the actual technology? Are you using Jenkins or like, I don't know?
So we use Jenkins, but we've Dockerized it so we can scale it more easily. And I think, we use then a Kubernetes cloud where we have like 3 or 4 virtual machines where we actually run all of our builds. And then we just locally have bought the most powerful machine we could buy, and then we just spawn up a Docker for every build we do. So we use the Dockers as like consumables, so we just spawn it up, do a build, throw it away, and then we just spawn a new up the next build we do.
Okay, thank you.
Yep.
On the right-hand side, going side to side, right? I'm curious about your perspective on extracting code specifically into Gradle modules. There's obviously an overhead with that in terms of configuring CI, configuring all your builds in order to have those hard dependencies. Why do you think that's advantageous over just having a single module and just defining a Java interface to do the same type of thing? Why do you think extracting things out into separate Gradle modules is worth that additional cost?
So I think if you think about future-proofness, so your app is only going to get bigger, right? So the modularization, I really think like it's essential because it allows you to scale easier, because then you can just like, you can even outsource a module to a separate company. You can just, in the team, easily say like, you work on that module, I work on this module, so then you hardly have any merge conflicts. You have the incremental builds that make things go faster. And so on the longer perspective, I think modularization will come into picture at some point anyway. So that's why I say like, yeah, if you think about it that way, then why not start already today? But then obviously, you don't want to like only have like 3 classes per module, and then just, if you slice it too small, then also you're going to lose a lot of benefits, right? So what my advice would be is you take your app as is, and you first think of the feature axis, and then you slice it in feature modules. Ideally, the easiest things are stuff where you can just get a contract in place where start activity with some parameters and then get a result back with some parameters. So do those solutions first. So then at least you can have the divide and conquer approach where you can make stuff better or rewrite it. And then just evolve from there. So we're also not yet in that state. I'm myself a bit scared of moving towards a project where we have like 150 modules. But for sure, like having 10 or 15 modules, that would make sense in our case. So always, yeah, be very critical of what you do, right?
One last.
So I understand that we have to mainly fix the bugs that we can reproduce, and that we have to have most automatic tests that we can. But sometimes you have things that are really hard to test and really hard to automate, like when you are working with bloaters and you want to connect a device, it will really depend on how the constructor will handle the Bluetooth and how it is implemented. So, and it can be really hard to reproduce too. So really hard to monitor. So what's your what's your point of view about that? Do we have to just ignore some bugs because it's too much time consuming, or do we have a way to fix this issue?
Yeah, so that's a great question, because you can literally test anything. Everything is testable. But at some point, the effort you need to put in order to make it testable doesn't outweigh the benefit you get out of it. And like Bluetooth is a very good example. We do communication over HTTP, and it's very hard to get the connection part to get that to run stable. So then what you could end up with, if you automate that, then okay, it's automated, which is great, but then your tests are gonna run flaky, so then the value you get out of it will be less, right? So what we're actually doing is, we are slicing our tests. So we do unit tests, then we do component tests, where you start at the UI level, or even a layer under the UI at your presenter, or view model level. And then you just test everything, but all of the external dependencies, you just completely muck it away. So you don't do the actual Bluetooth communication, you don't do the actual network request. And if you slice it like that, those tests, they should run 100% reliable. There's no reason why they should still be flaky. And that's the kind of thing we do for a pull request, because there we really, if it fails, there needs to be a problem, right? And then every night, we run those end-to-end tests. Because all of those Bluetooth connection scenarios and those worst case thingies, it can be very tedious to reproduce them manually. So what you at least want to have is like two things. You want to be able to do a very quick check where you can still see like, hey, is our app still working? So that's one thing you'd like to have in place, where you just run through some common scenarios. And then the other thing is those very tricky cases, which are hard to reproduce manually. Probably you'll also want to automate those, because then you just can, for instance, like doing a firmware update, that would be something you really want to have automated, right? Because it's hard to reproduce manually, and if that breaks, it's going to be business critical, and then you're going to have a big problem. So, like in anything, you need to like balance the things, and then just try to make the right decisions. But if you don't have a test suite yet that runs super fast, super stable, so if you don't have your unit testing game together, then I wouldn't recommend to start working on component or integration tests. Because the more stuff is between your test and what you're hitting, the more places where it can go wrong, right? So you at least want to know that those layers at least work by themselves before you start testing them end to end. You're just gonna have a frustrating experience then.
Thank you.
Okay, thank you everyone.